In this video, you're going to learn about the service models currently available in Azure OpenAI. First, let's talk about the GPT 3.5 models, which, in case you didn't know, GPT stands for Generative Pre-trained Transformer. In summary, it's an artificial intelligence tool that can understand and generate text in a way similar to how humans do. If you've used ChatGPT for free, you've likely seen some of these models selected when using the website. The members of this family today are GPT 3.5 Turbo, GPT 3.5 Turbo 16K, and GPT Turbo Instruct. This is a good time for you to know that these models are constantly updated, and by the time you watch this video, there may be a new models within the families. For example, if we go to the OpenAI portal, in the description of the GPT 3.5 Turbo family, you will notice that the GPT 3.5 Turbo 16K model is marked as Legacy, which means there are newer models with greater capabilities. Returning to the Azure portal, you will also see a series of notices showing how long the models will be available, so you can replace them with other options. The best and most cost-effective model to use from the GPT 3.5 family is GPT 3.5 Turbo, which has been optimized for chat tasks and performs quite well with completion tasks. On the portal, you will also be able to see model features, such as the model version, the maximum number of tokens we can use in the model, and information about the last model update date. Let's do a test on the ChatGPT portal to see how ChatGPT would draw a dinosaur in ASCII format. You may or may not like the dinosaur generated by ChatGPT. The second family of models is GPT-4, which can solve difficult problems with greater accuracy than any of the previous OpenAI models. Like GPT 3.5 Turbo, GPT-4 is optimized for chat tasks and performs very well for completion tasks. The models that are part of this family today are GPT-4, GPT-4 32K, and GPT-4 Vision. Here we can see the table showing the capabilities of the GPT-4 family models. You can see that the capabilities in terms of the number of tokens that can be processed are much greater, and in some cases the update date is more recent. You must take into account that models marked as preview are not recommended to be included in production, as they can sometimes be unstable. Let's return to ChatGPT and test the same prompt for the model to draw a dinosaur in ASCII format, and compare the result with the previous generation. From my point of view, this result has been spectacular, which proves that this family of models handles complex tasks in a better way. Lastly, this family of models also includes the Turbo with Vision model, which allows inspecting the content of an image and obtaining information about it. Let's put it to the test and see how well it can recreate a simple mockup in HTML code, indicating that we want the HTML code and the CSS code separately. Particularly, this model surprises me a lot, and I have several use cases in mind where this model could be applied to solve problems that were previously impossible. Once the result is obtained, I'll go to CodePen to test it. You can see that although the code is not perfect, we can definitely use it as a starting point to save several minutes and not start from scratch. Now, remember that these are the first versions of the Vision model, which will surely improve over the months, providing us even more amazing experiences. The third family of models is called Embeddings, which consists of a single model called Text Embeddings ADA02, and is used to convert text into numerical vectors to facilitate text similarity. What does this mean? Well, we've already seen that the GPT 3.5 and GPT-4 models have a token processing limit, in addition to the fact that the more tokens you use, the more money you will spend. That is, if you wanted, for example, to process a scientific article with GPT-4 to answer some questions, you would have to send the whole context of information over and over again so that the model knows what you are talking about. This would result in a huge amount of tokens used for each question. With embeddings, what you can do is break the document into pieces, generate numerical vectors for each piece, and store them in a vector database. This will allow you, when you want to ask a question, to generate the numerical vectors of the question, search the database for the most relevant sections of the document based on vector similarity, and obtain only the piece or pieces most similar to the question, which you could send to the GPT model to answer the question, based on the context sent. This drastically reduces the amount of tokens used. The next family of models is DALL-E, which allows generating original images from natural text. This family is made up of the DALL-E 2 and DALL-E 3 models. DALL-E 2 allows image generation with a prompt of up to 1000 characters, while DALL-E 3 allows 4000 characters, which opens the possibility to be more specific in the details of the image. The fourth family of models is Whisper, which allows transcribing and translating voice to text. These models have been trained with a huge dataset from various audio sources. This family consists of the Whisper model, which I have personally tested and been surprised by the results obtained, both in terms of text retrieval and punctuation placement. As an additional piece of information, you can provide the model with a file of up to 25 megabytes to obtain the text. The fifth family is text-to-speech, which includes the models TTS-1 and TTS-1 HD. These models allow converting text into natural audio. The TTS-1 model is optimized for real-time experiences, while the TTS-1 HD model is ideal when you need quality.